to the Startup Lab ShopBot. ShopBot wood router, or it's like a CNC, which means it's controlled by a computer. Computer controlled wood cutting. Plastics, wax, cannot do metals like aluminum, steel. That's a regular CNC. So this is more wood, those type of materials. Behind me is the ShopBot. Probably of all the machines that we have in our lab, this is the most dangerous. I don't want to use the word dangerous to make it, scare anyone. It's just, it is something that is computer controlled with a motor that can grab you if you're not careful. So if we look at the ShopBot right off the bat, you can see right here, hopefully you can see, there's a tooth or like a rack and pinion, and then this body, this carriage moves back and forth. So this is the area where you could get your hand caught. When you do come to use this, we're going to have this marked off so you can't reach in there. I don't have it on today. But just so you understand, this is a no-no, any reaching or grabbing over like that. The machine is laid out in an X, Y, Z coordinate system. So again, this is the router head that will move. The way that this is laid out, the length of the machine is the x-axis, back and forth is the y-axis, and the router itself up and down is the z, and that is the way you'll also do your program. Here is your working surface. If you look closely, you may recognize this material. It's just MDF 3/4 inch 4x8 sheet you can get from any Home Depot. It's called a spoil board because you can spoil it. In other words, you can cut into it. So we take whatever we're doing, bolt it to the spoil board, and not in this case because we stopped before the thickness, but in many cases you'll cut through and into the spoil board. I don't know if the video can see, but you can even see lines on our spoil board from past projects. As this turns to Swiss cheese, we rip it off, put a new one, level it. So again, the spoil board is meant to be cut into. So that takes some of the pressure away and you can cut through materials. So moving carriage XYZ, it is wood. It is plastic, which means it's going to make particles, or especially in the wood, sawdust. Sawdust is dangerous, believe it or not, when you have an environment of electronics because it makes dust and powder. So because of that, this machine is hooked up to a tube system to a dust collector, and it does a fantastic job of sucking up almost all of the dust and all of the debris, which is really important. Hooked to the ceiling. Now there is the issue of the bag gets filled, so as you're working you may want to check to see is the bag full. Also you want to make sure that the dust collector is on when you're working. So now that you've had a basic introduction to the machine, the next step is to load the tool, or what tool are you going to use for your job. And that tool is located underneath what's called the dust skirt. I could have had this all prepared, but I thought it was more important for you to see how to get to the tool, because right now it's down low, so I'm going to show you how to get that up to where it's at a working height. And what we do first is go to the computer. So on the computer, a couple things to note. Number one is there's a USB cable from the tower of the computer to the machine. That has to be plugged in. Nothing happens on this machine if it's not communicating to the ShopBot. It will just give you an error. So number one, that has to be plugged in. So on the desktop you're going to see an icon that says ShopBot. That's the main operation program for this machine. You will open that and hit the magic key K. Why is it K? I don't know. That's the hotkey that the program picked. You hit K and you'll see a yellow jog window open. As long as our computer is plugged into the machine, and it has power of course, these jog buttons are live and active right now. And the reason I'm showing you this is, again, we're loading the tool and I'm going to use these jog buttons to move the machine. If you look at these buttons, there's a left, right, up and down. But what we have to do is you need to think of these buttons being exactly the same direction as what the machine is sitting. In other words, if I hit the left button, it's going to pull our carriage to the left. If I hit the up button, it's going to move the carriage back towards our wall. Down button will pull the carriage away from us, and the right button will move the carriage back in that direction. And I always think if you were I take this screen and lay it flat, those buttons would all be pointing in the correct direction of the movement. Lastly are these two buttons, Z up where the tool is, the router itself, and Z down. So Z up and down. Okay, so using my jog window that I've opened, I'm going to raise the Z, a little up arrow. I'm keeping in mind right now, how high do I need to be to get good access to that tool under there? 6, 7, 8 inches, something like that. I'm going to now position the carriage more to the middle so it's a little easier to work, a little more elbow room. And I'm going to bring it closer to me in to help me with the tool. Underneath this skirt, there's already a tool in there, and I'm going to change it to the tool that I'm going to select for making my part, which will match in our code. So in our electrical panel, there's a key. You take out the key, voila, there's one of our two very important tool removal wrenches that will always, one of them will always be hanging, the other one is over in our tool area. So I come over. But before I remove the tool, I have to take off the dust skirt. I'm going to bring the tool down. The tool was a little bit too high, which may as well happen to you. And there's a little set screw back there. There we go. Bring the tool back up. So let me review. You want the tool low enough to remove the set screw to take the dust skirt off. Then I brought the tool back up now that that is out of my way. Now that your Z has been lifted, dust skirt removed, we take our two wrenches, and underneath here are two nuts that work opposite each other to loosen. One goes on the bottom nut, one goes on the top, and I just turn in the direction to loosen. I have to remember which way. There. It shouldn't be that hard to remove, so if you're going in one direction, it's very, very difficult. Try the other direction. It shouldn't be that hard. Unscrew it, and I have in my hand the collet that threads in. The collet in this particular case is a 1/4 inch, which matches the shank size of this particular bit. I'm also going to be using a 1/4 inch. If there are some end mills that are 1/2 inch, 3/8, and you would have to have the matching collet. But in this case, the 1/4 is correct. So I'm going to go get my other bit. I put the collet back into place. You don't want to fully tighten it. Have the tool. Now you tighten it by hand as much as you can. Come back. 1 wrench on the bottom, 1 wrench on the top, and just snug it. You don't have to go too strong. Just nice snug. It's not going anywhere. And that's how you change a tool. After your tool is in place and tightened, we put the dust skirt back on. There's a little port back here that slides up to the top. A little set screw in the back that you have to be here to see, but you just turn it until you feel it catch. Give it a nice little push and the dust skirt's back on, and that's how you load a tool. Everything's ready on the machine, so now it's to the program. So we already talked about there's a ShopBot program for jogging the head around, but now we're going to another program called PartWorks. PartWorks is also came with the ShopBot, but this is the program where you set up your workpiece, what pockets you're doing, the text, etc. And that is an icon also on the desktop. When we have the program open, we go to File, New, just like you do with all programs, and we get what's called Job Setup. And at this point, this is where you need to be thinking, or you should know a little bit ahead of time of what you're making. And in this case, what I'm going to do today, nice cheap old 2x4, I'm going to write ASU Poly. into this board, a real simple text operation. You could do pocketing, you could do complicated scroll work, all depending on what program you're bringing in or what tool you're using. Also, if you do design something in a SolidWorks CAD program, if you look straight at your part, in other words normal to it, so not skewed but normal to it, and hit Save as DXF, it will capture whatever lines in your SolidWorks part and save them as vector lines. Why would you want that? That's something that you could import into this program that our tool could follow. It could do a pocket width, it contour, all types of different operations. But today I'm just going to type text on this board and cut some letters. So one of the first things I need to do is measure the length of the board. 24 inches by 3.5. It's very important to know your work area. Thickness, 1.5 inches. So in my job setup that pops up, we're going to have a height of 24 inches, width of 3.5, and it also says thickness 1.5. If you look on the screen, that's my board. Now, as we did with the jog, this monitor is basically, it is the ShopBot surface turned up 90 degrees, just like this. Just like if you were to just take the machine and lay it on the wall. So if you look, this board is vertical. It will be that same orientation in the machine. That's important. This is just almost like you lay it down exactly like that on the workpiece, and you'll see that in a few minutes. So we're happy, we hit OK. And now we're ready to create our text. So I'm going to type in ASU Poly, all capital letters. You can click here if you want and pick your text. I'm going to do a nice simple bold text. And I'm going to even make it more bold by clicking bold. I'm trying to put my tool inside the letters. So I want a nice, simple, thick text. Height of the letters, I'm going to put 2.5. And apply. Now that I've entered my text, I'm going to drag it to the location I want. You can put it freely anywhere. You could also put dimensions, but I'm just going to put it somewhere nice in the middle of the board. FYI, when I first entered my text, it kind of popped it off the screen. So if you enter something and it disappears, it may just be that it's off the screen a little bit. You need to zoom out and move it. So that's a nice location there. We're done with our 2D entering of lines, or in this case text, and I'm ready to switch over to the toolpath creation information, which is this little blue arrow right here. If you notice, all the buttons now are on the right-hand side. That's toolpath. I can go back to drawing tab, and that's on the left. Right hand is toolpath, left hand is the art creation. I have everything selected. And I come over here, and my choices are profile or pocket. Profile would be if I wanted to cut outside the lines. I'm going to do a pocket on the inside, so I click pocket. Okay, at this point, we have to select our tool. So I'm going to select. We want a 1/4 inch straight. That's what I put in there. All the feeds and speeds and how fast it spins, I let the computer tell me that. And you can also tell it the material. It defaults to wood, which is what I'm using. But if, let's say you were using a plastic, you can choose that material and it will tell you how fast to move and spin the cutter. It takes all the pressure off of you. So I'm just going to leave all the settings. I hit OK. Up here it says cut depth. Well, the board itself is 1.5 inches. I'm just going to go about maybe 1/2 inch deep, 0.5. And that's it. Calculate. There aren't more settings, but for what we're doing today, that's all we need. There, I moved the machine back just to have a little bit of breathing room. Before you got here, I found a drill with a bit that's just a little bit smaller than the wood screw I'm going to use just to create a pilot hole and make it easier for insertion. Our spoil board has been squared, so I, with confidence, can lay this board right on the edge of this spoil board as a guide. So now that our part is secure and held to the table, again, remember I used wood screws. Your project may be completely different. If you're doing some kind of an outside cut, you may not use this method because you don't want to hit the bolt head. You may, in that case, use hot glue. There's even vacuum tables. But in this case, I have it bolted down, and now it's time to zero the part. And to do that, I have to go back to my jog window. We hit the magic K button, and I'm going to bring the machine towards me. My goal is to take the tip of that tool and get it as close as I can to that front right corner. And drop my Z down a little bit. There's no hurry in doing this. Take your time and get it right. So that I don't want to hit the part, but I'm about a 1/4 inch above and I can eye it pretty well. So over here on the program, so I'm looking, we're going to enter in the program the location that this is the Y direction, so our Y is right on that edge. I got lucky. You would nudge it back and forth, but right now if you were to draw a center line, it's right on that edge, so I got lucky on that one. I come over here to 0, and I say 0 Y axis. Now we're going to bring it forward in the X, just a little bit. I'm going to look down my part. And I'm getting lucky today, that's right on where I need it to be. Now I am eyeing it, and you may say, what if I need it to be exact? There are zeroing tools that you can use to get very, very, very accurate, but remember, working in wood is not like with metal, aluminum, steel, where it's perfect. Wood is a little bit more of a forgiving environment, but I'm eyeing it, and it's right on my X, so I'm going to come over here, and I'm going to say, there's a menu that says 0 x-axis. My X and Y have now been zeroed. Only thing left now is the height of my Z. And the way I do that is I'm going to come over and we're going to touch the top of our part using what's called a zeroing plate. Okay, so my jog window again is up. I'm going to move the machine back. I'm moving it to the center of my part using the jog. In this case, I want to bring the Z up. We're going to use what's called a zeroing plate, where it touches and creates a connectivity to let the machine know that the part is at the top of the machine, and that's this guy. This is a zeroing plate. We put the plate underneath the tool, and this is a clamp to go around the end mill. So it's really very simple. When the tool touches the aluminum, it can see the connectivity and it knows that it's 1/8 of an inch above the part, and it handles the rest. So we're all hooked up. I come over to my computer. Under what's called cuts, you're going to say 0 Z-axis with plate, one of the selections. It's saying, is the Z plate ready? Yes. And there it goes. It's going to go down until it touches. That's always the scary part. You think it's going to hit and break, but as long as you have it hooked up like this, you'll be fine. It's going to touch one more time as a backup. And voila, X, Y, and Z are zeroed, and it matches our program, which is very important. We're now going to put the plate away. Set up to the plate. And we're ready to cut some letters. Okay, so before you cut, there are 2 very important steps that if you do not do, you're either going to break the tool or make a mess. And that is, number 1, turn on the key. This gives power to the router. In other words, the tool spinning. If you do not do that, and I've seen it done many times, you're going to come over and drive the tool into your material and break it. So turn on the key. And the other one is, turn on the dust collector. Without this, dust goes everywhere. We're ready to go. Let's rock and roll. I opened the ShopBot program. I loaded in my code. I hit OK. There we go. I already turned off the dust collector, turned off the key. Again, 2 important steps, especially the key. That's a safety aspect of the machine. We are done. I need to back the machine up. You know how to do that by now. I hit K. We jog it back. Take our drill, reverse it, back out. Kind of cheap wood, so we got a little bit of, lost a little bit of the island on the A. That's what you get. This is like that, what, about $1 something for the 2x4, but still, nice job. Could never make this by hand.